Welcome to the chemistry class. Today we are going to discuss about certain terms or certain notations which are very important. As you know, in case of SN1 and SN2 we are talking about the inversion product, retention product and chirality and chiral carbon, all those terms we are talking about like optical activity. So today in this class we are going to study in detail regarding those terms. Clear? So let me explain you regarding the plane polarized light. So what is the meaning of the plane polarized light? See here, normally ordinary light will going to vibrate in all direction like this. Ordinary light will going to vibrate in all the directions of a plane. This is the ordinary light. So here this will going to vibrate in all the directions, but plane polarized light we are talking means it must be, the vibration must be confined to a plane. So how the ordinary light can be converted into plane polarized light? Just pass this plane polarized light through a Nicol prism, so that the ordinary light is converted into plane polarized light, It means the vibrations of these light is confined to a plane like this. Okay, to the one plane the vibrations are confined. Such a light is nothing but plane polarized light. This is what we called as plane polarized light. Clear? So ordinary light will going to vibrate in all the directions. When the ordinary light is passed through a Nicol prism, we are going to get the plane polarized light. Plane polarized light is nothing but the light whose vibrations are confined to a plane, to a single plane, that is nothing but a plane polarized light. So when it is passed through, we are going to get the plane polarized light. Clear? So next we will come across the term like optical activity. Optical activity is nothing but the property of the compound to rotate the plane polarized light. The property of the compound, that is optically active compound. Optically active compound means that must contain the chiral center. What is chirality? That I will going to discuss. Okay, optically activity is nothing but the property of the optically active compound which can able to rotate plane polarized light. That only I wrote shortly PPL, plane polarized light. Such a property is known as optical activity, and the compounds which are possessing the optical activity property, those are called as optically active compounds. Optically active compounds. Okay, see here compounds, and this is the optical activity. So optical activity is nothing but the property of the compound by virtue of which it can able to rotate the plane polarized light. This plane polarized light, if the compound can able to rotate, for example, suppose I got the plane polarized light and in a beaker I am going to take one of the compound. Suppose this compound can able to rotate this plane polarized light, means the property which is possessed by this compound is what we called as optical activity. This is what we called as optical activity. That is only, it can rotate either clockwise or anti-clockwise, but that rotating property is nothing but optical activity. So, the property of the compound which can able to rotate the plane polarizer light is called as optical activity, and the molecules which possess such a optical activity property, those are called as optically active compounds or optically active molecules, we can able to use the term. So, let us come to the optical isomers. What is the meaning of optical isomers? Isomers, you know it already. So, here optical isomers means the compounds which are having the same molecular and structural formula, but only differ their action on the plane polarized light. First, let me write the compounds which have same molecular and structural formula but differ in their action on plane polarized light. Such a compounds are called as optical isomers, and the phenomenon is known as optical isomerism. And the phenomenon is known as optical isomerism. Are you getting? See here, optical isomers means the compounds which are having the same molecular and structural formula, but their action on the plane polarizer light is different. Suppose some of the compound can able to rotate the plane polarizer light towards the right, some can able to rotate it towards the left. That action will be different. Those compounds are having the same molecular and same structural formula, but only they are going to differ in their action on the plane polarizer light. Those are called as optical isomers, and the phenomenon is said to be optical isomerism. Clear? So, let me tell you one more important term, that is chiral carbon, or it is also called as asymmetric carbon, or it is also called as chiral center or stereo center. Sometimes even they are going to use you stereogenic center. So, all these are the alternative names for the chiral carbon. Chiral carbon is nothing but the carbon must be attached to the 4 different groups. If the carbon is attaching to the 4 different groups, like let me take this is H, this is Cl, this is CH3 and this is C2H5. Clear? Suppose the carbon is bonded with the 4 different groups, means that carbon is said to be a chiral carbon, which is represented by a star mark, So, this is the definition of the chiral carbon. Okay. And then one more thing I want to tell you, that chiral molecules or the chiral carbon, it means the carbon must be attached to the 4 different groups. Sometimes the people think here C2H5, it means it is attached to a single carbon, it is ethyl, like this it will be there. Okay. So, if the carbon is attached to the 4 different atoms or 4 different groups, that a carbon is said to be a chiral carbon. Clear? And then one more thing I want to tell you here, as I said you optical isomers, as the optical isomers can able to rotate the plane polarizer light, their action will be different. So, on the basis of their action, the compounds are, I hope so you got all these points. I want to rub this one. See here, just look at this. Ordinary light is passed through a nickel prism, we are going to get the plane polarizer light, and then when this plane polarizer light is passed through any one of the optical active compound, This is the optical active compound, and then suppose this optical active compound rotate the plane polarized light towards the right side. It means clockwise direction. It means clockwise direction. These are called as dextrorotatory. It is said to be a dextrorotatory. Okay, it is represented by small d and it is represented by the plus sign. If the plane polarized light is rotated in the clockwise direction, that a compound is said to be a dextrorotatory, or it is represented by d and sign, that is plus sign. Okay, suppose this optical active compound will going to rotate the plane polarized light towards the anti-clockwise direction, that is towards the left, like this, anti-clockwise, clockwise like this, anti-clockwise like this. If it rotates the plane polarized light towards the left or anti-clockwise direction, means that is what we called as levorotatory. Levorotatory, which is represented by small l with the negative sign, Clear? So, suppose the PPL is rotated to the clockwise direction, it will going to get the dextrorotatory compounds. If it is rotated towards the left, that is anti-clockwise direction, we are going to get the levorotatory compounds. Clear? Suppose, let me tell you here only, that is racemic mixture, what we talk about in case of SN1 reaction, racemic mixture. Suppose this is a plane polarized light. Okay, I am passing this plane polarized light to the mixture, optical active compound mixture, and just imagine this is having both D type of the compound and L type of the compound. Okay, this is this will going to, it is a mixture. It is a mixture of D and L. So that what happens then? What about the rotation of PPL? Whether it will going to rotate clockwise or anti-clockwise? No, it will not going to rotate clockwise or anti-clockwise. It will be in the same. Why it will be same? See here. As I said you, dextro wants to rotate the plane polarized light towards the clockwise direction, while levo wants to rotate it towards the anti-clockwise. It means both are opposite action, both are opposite. Those two actions are opposite, those will going to be cancelled with each other. So, the plane polarized light will pass it as it is. So, racemic mixture, this is what we called as racemic mixture. It is the equimolar mixture of D and L, that is a dextrorotatory and levorotatory type of the compounds. It means the equimolar mixture which consisting of the both dextrorotatory and levorotatory compounds, so that their action on the PPL is cancelled with each other, because one wants to rotate in a clockwise and another wants to rotate in a anti-clockwise. It means what about the rotation of PPL? It will not going to rotate because both the actions are opposite to each other. It is passed as it is. Okay, so this is what we called as racemic mixture. Racemic mixture is the equimolar mixture of dextro and levorotatory compounds, so that the action of this on the PPL is not at all observed. It means the PPL is passed as it is, Clear? So these are the terms which are very important terms I am going to explain you in this class. Clear? First one is plane polarized light, which means the vibrations are confined to a single plane, that is the plane, that is what we called as plane polarized light. And how it is obtained? The ordinary light is passed through a nickel prism, so we are going to get the plane polarized light. Suppose then we will come across the optical activity. Optical activity is nothing but the property of the compound which can be able to rotate the plane polarized light, and the compounds which possess Such a property are called as optically active compounds. Those are called as optically active compounds. Let us come for the next one more term, optical isomers. Optical isomers is nothing but the compounds which are having the same molecular and structural formula but differ in their action on PPL, that is plane polarized light. Those are called as optical isomers, and the phenomenon is called as optical isomerism. Clear? And suppose if the action is different, just see here PPL is passed through a optically active compound. Suppose this compound rotates the plane polarized light towards the clockwise direction or towards the right, that is said to be a dextrorotatory, represented by D and the plus sign. If it is rotate that PPL towards the left, that is anti-clockwise direction, that is what we called as levorotatory, which is represented by the small l and the negative sign. Clear? So, here one more term, that is chiral carbon or asymmetric carbon or chiral center or stereo center. Okay. If the carbon is attached to the 4 different groups, if the carbon is attached to the 4 different groups or atoms, and that carbon is said to be a chiral carbon, and that is represented by a star, that is represented by a star. Let me take like this, C2H5 and CH3. This carbon is nothing but a chiral carbon or asymmetric carbon. And then we are talking about the racemic mixture. Racemic mixture is the equimolar mixture of dextro and levorotatory compounds. Okay. And suppose if the PPL is passed through a mixture that is consisting of both D and L type of the compounds, means the action of, that is the PPL will going to be, there is no action of these compounds on the PPL because dextro is also there, levo is also there. So, it is passed as it is. So, this is nothing but a racemic mixture. So, all these are the terms which I have explained are very important, and sometimes they are going to ask you define optical isomerism, okay, and sometimes they are going to give you what do you mean by chiral carbon or asymmetric carbon, and sometimes they are going to ask you what is the meaning of optical activity. Those we are going to ask you for 1 mark. I hope so all the concepts are clear. Okay. Further we are going to discuss certain few more concepts in our next class. Thank you.